Hello everyone, welcome back to my channel Explain Maths. Now in this video I am going to start with the second chapter of grade 10 and the topic is polynomials. So in this video I am going to cover the introduction of the polynomials where I will do a quick recap of whatever concept you have studied in grade 9 and then I will explain the geometrical meaning of the zeros of the polynomial. So let's begin the class. So first of all we will see what is a polynomial. So polynomials are mathematical expressions which is made up of variables and constants by using arithmetic operations like addition, subtraction and multiplication. Division of the variable is not allowed in the polynomial. So for example, I have taken x square minus 3x plus 2. This is a polynomial and you can see it has a variable x and it has a constant also 2. And they are connected through, if you see 3x, it is connected through multiplication, then there is a subtraction, there is an addition, okay. And if you see this polynomial is having three terms. First term is x square, second term is minus 3x and third term is 2. So this is a polynomial. Now in a polynomial, exponent of the variable should be a non-negative integers. Now exponent of the variable means the power of the variable should be non-negative. So here if you can see in the previous example, the power of x is 2, here the power of x is 1. So it should be a non-negative integers. So suppose if I have taken x plus 1 by x, so this is not a polynomial. Reason is x plus 1 by x I can write as x to the power minus 1. And what we have told just now, no, it should be a non-negative integer. So this is not a polynomial. Now next is root x minus 3. Root x means the power of x is 1 by 2 minus 3. Again it is not an integer. So this is also not a polynomial. So you have to be very careful when the question comes like identify which is a polynomial. So you have to take care of all those things. The power of the variable should be a non-negative integers. Now next we will try to recall the degree of the polynomial. Okay, so if px is a polynomial in variable x, the highest power of x is called the degree of the polynomial. So let's see few examples. So if it is 4x plus 2, the variable is x and the highest power of the variable x is 1, isn't it? So it is a polynomial in the variable x of degree 1. Now next is 2y square minus 3y plus 4. So if you see here the variable is y. Here power is 2, here power is 1. So highest power of y is 2. So the degree of this polynomial is 2. Next, 5x to the x cube minus 4x square plus x minus 5. So here you can see variable is x. Here the variable power of x is 3, here is 2, here is 1. And highest power is 3, so the degree will be 3. I hope it is clear how to find out the degree of the polynomial. Now next we will see polynomials of various degrees. So first is linear polynomial. A polynomial of degree 1 is called a linear polynomial. And in general form of writing linear polynomial is ax plus b, where a and b are real numbers and a should not be equal to 0. Because if a will become equal to 0, then the first term will become 0 and it is left with only b. So the variable power will not be there, so it won't be called as a linear polynomial. Okay, so you have to remember the general form is fx equal to ax plus b, where a and b are real numbers and a should not be equal to 0. Let's take one example. Like 6z plus 8 is a linear polynomial and z. So here if you see the degree is 1 because the highest power of the variable z is 1. Now next is quadratic polynomial. So a polynomial of degree 2 is called a quadratic polynomial and it is of the form fx equal to ax square plus bx plus c, where a, b and c are real numbers and a should not be equal to 0. Again if a is 0 means this first term will become 0, so it will be bx plus c, then it will become a linear polynomial. That's why this condition is mandatory. A should not be equal to 0. Now the example is 3x square plus 4x plus 7 is a quadratic polynomial in x. Now next is cubic polynomial. A polynomial of degree 3 is called a cubic polynomial and it is of the form fx equal to ax cube plus bx square plus cx plus d, where a, b, c and d are real numbers and a should not be equal to 0. Because if a is 0, the first term will become 0, then the highest power of the polynomial will be 2, it will become a quadratic polynomial. The example is 3x cube plus 5x square plus 4x plus 7 is a cubic polynomial because the highest power of the variable is 3. So it is a cubic polynomial. Now next we will see what is a constant polynomial. So as the name suggests constant, it means it won't have any variable. So a polynomial containing one term consisting of a non-zero constant. The constant should not be 0 is called a constant polynomial. For example, 6, minus 8, 9 by 14. They all are constant polynomial. And the degree of a non-zero constant polynomial is 0. Next is zero polynomial. A polynomial consisting of one term, namely 0, is called a zero polynomial. And the degree of a zero polynomial is not defined. So you may see these type of questions in MCQ. Okay. So you should have a knowledge of all these different types of polynomial. If px is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in px is called the value of px at x equal to k, and that is denoted by pk. So now this is very much theoretical. Now I am going to explain this using some example. So I have taken a polynomial px equal to this. Now what it says, you have to take one k which will be a real number and the value obtained by replacing x by k. So let's take, I am going to put now in place of x as 2 and I am going to find the value of p2. So that's what. So what I am going to get? The value of p2 at x equal to 2 and it is denoted by p2. So let's find out the value of it. When you put the value of x as 2, what it will become? In place of x, it will be 2. So x square will become 2 square minus 3x means 3 into 2 minus 4. So 2 square will be 4 minus 6 minus 4. Now 4 minus 6 will give me minus 2 minus 4. So it will be minus 6. So the first value I got here as minus 6. Now next I am going to take different values of x. So now I am going to put x as minus 1. So let's see what will happen. So it will be minus 1 square. Now I am checking this again in the same polynomial. Minus 3 into minus 1 minus 4. So minus 1 whole square will give me 1, minus and minus plus 3 minus 4. 1 plus 3 is 4 minus 4 which will give me 0. Right? Now let me take another value also. So now take x equal to 4. So P4 will be equal to 4 square minus 3 into 4 minus 4. So 4 4s are 16 minus 12 minus 4 and 16 minus 12 will give me 4. So 4 minus 4 equal to 0. Now if you see here clearly, for some values of x when you put, suppose x equal to 2 when you put in the polynomial, you get the value as minus 6. When you put minus 1 and 4, the value you got as 0, isn't it? So as p minus 1 is equal to 0 and p4 also equal to 0, we will say minus 1 and 4 are called the zeros of the quadratic polynomial this. Okay, why zeros of the quadratic polynomial? Because when you give the value of x as minus 1 and 4, we got the value it as 0. So in more general, what we say, a real number k is said to be a zero of the polynomial px if pk value will give me 0. When you put the value of x as k, if you get it as 0, we will say k is the 0 of the polynomial. Okay, so I think you are able to understand now when we say it is a 0 of the polynomial. When you put some value of x which gives the complete value of the polynomial as 0, we will say that value of x is the 0 of the polynomial. Okay. Now next we will see the geometrical meaning of the zeros of a polynomial. So first I will discuss about the linear polynomial. So we already know that the graph of a linear polynomial is a straight line. You must have drawn many graphs in your grade 9, right? So linear polynomial graph is a straight line graph. So I have taken a linear polynomial y equal to 2x plus 3. Okay, when I plotted this, the graph of this, I have got a straight line which passes through the point -2, -1 and 2, 7. Now what is the meaning of these coordinates? It means when I put the value of x as -2 in this polynomial, I got the value of y as -1. So let's check it. So when I put the value of x as -2, so what will happen? It will become 2 into -2, which will give me -4 plus 3, which is -1, right? That's what I've written here. Same way, if you put the value of x as 2 in this polynomial, so y equal to 2 into 2 plus 3, which will give you 4 plus 3 equal to 7. And now you have to plot the graph of it. So when you plot the graph, you will get a straight line like this, isn't it? And you can see here this straight line is intersecting here at this point, which is between -1 and -2, and this coordinate is -3 by 2 comma 0, isn't it? And we also know that we have already studied how to find out the zeros of a polynomial. So here you can see this is a linear polynomial 2x plus 3. Now if you have to find the zeros of the polynomial, try to recall what we used to do. We used to write 2x plus 3 equal to 0, and which gives me the value of 2x as -3, and if I transpose 2, I will get x equal to -3 by 2. So that you can see clearly over here also at this point. Okay, it is intersecting here in the x-axis, isn't it? So from here you can conclude that the zeros of a polynomial is the x coordinate of the point where the graph intersects the x-axis. So you can see this graph is intersecting the x-axis at this point, isn't it? Don't get confused. This is the y-axis point, intersection point. X-axis, it is intersecting at this point, and this point is -3 by 2 comma 0, isn't it? So we can say that the zero of the polynomial is the point where the graph intersects the x-axis, isn't it? That you can see from here. So this is only the geometrical meaning of the linear polynomial. Okay. So in general, we can say for a linear polynomial ax plus b, where a is not equal to 0, the graph of ax plus b is a straight line which intersects the x-axis at exactly one point, and the point is -b by a comma 0. So let me explain it again. In the previous slide, just now I have used this linear polynomial, isn't it? And when we solve, what did we get as a zero of the polynomial? We got the value of x as -3 by 2, isn't it? And if you try to relate with this, okay, your b here is 3 and your a is 2. So from here minus b by a will be equal to -3 by 2, isn't it? That's what we got as a zero of the polynomial, isn't it? And as it is a linear polynomial, you will get exactly one point where the graph will intersect the x-axis. And I have showed you the graph also, right? It was intersecting only at the one point, and the point was -3 by 2. Okay, and y-axis coordinate will be 0. So from here I can conclude that the linear polynomial has exactly one zero, namely, and what is that zero? It will be the x coordinate of the point where the graph intersects the x-axis. So I hope it is clear now. Now next we will see for the quadratic polynomial. Now next we will see the geometrical meaning of a zero of a quadratic polynomial. So first let me take one quadratic polynomial. It is x square minus 3x minus 4. Now I am going to plot the graph for it. So for that I have to make a table where for different values of x, if I put, I will get the value of this polynomial as, when I put x as -2, I got it as 6, then -1 I got as 0, and so on. And based on this data, when I plotted the graph, I have got something like this. Okay, and this shape is known as the parabola. Okay, you'll study in detail in higher grade what is parabola. You'll study in your +2. So this shape is known as a parabola. Now, for any quadratic polynomial, if you see, the shape which you will get, it will be either open upward or open downward, depending on whether the value of a which you have taken here is greater than 0 or less than 0. Okay, so if it is greater than 0, it will be open upward like this figure, and if you take the value of a less than 0, then it will be open downward. Okay, downward means it will be something like this. Okay, it will be something like this, and now here it is upward. So now here, if you see in the graph, okay, the graph is intersecting the x-axis at 2 points. You can see here, one point is -1, 0 and one is 4, 0. So in quadratic polynomial, here you can see for this case, you can see there are two zeros, isn't it? And we already studied in grade 9 that how to find the zeros of the polynomial. So if you see x square minus 3x minus 4, if I don't have to plot a graph without plotting, if I have to find the zeros, what we used to do? We used to write x square minus 3x minus 4 equal to 0. And let's factorize it. So it will be x square minus 4x plus x minus 4 equal to 0. So x, if I take common, it will be x minus 4 plus 1 x minus 4 equal to 0. So it will be x minus 4 into x plus 1 equal to 0. From here I will get, if you take x minus 4 equal to 0, you will get x as 4. And if you take x plus 1 as 0, you will get x as minus 1. Same thing you can see here, x equal to 4. That point is over here. And here is x equal to minus 1. Isn't it? So the zeros of the quadratic polynomial are the x coordinate of the point where the graph intersects the x-axis. Same thing we have seen in the linear polynomial also. Okay, there also we have seen the zeros was the point on the x coordinate where the graph intersect the x-axis. Here also it is same thing. Okay, here in this case I have seen there are two zeros of the polynomial. Clear? Now in quadratic polynomial there are three cases. Now the first case is if the graph cuts x-axis at two distinct points A and A dash. Okay. So the x coordinate of A and A dash are the two zeros of the quadratic polynomial. So this can be the case. Now depending on the value of A, the graph, this parabola will be open upward or downward, isn't it? If A is greater than 0, it will be open upward. If A is less than 0, it will be open downward. So this is the first case where you will get two zeros because the graph is intersecting the x-axis at 2 points. Clear? Now we will see the second case. Now case 2. Here the graph cuts the x-axis at exactly 1 point. That is at two coincident points. So the 2 points A and A dash of case 1 coincide here to become 1 point A. Now let's take one example. Suppose my quadratic polynomial here is x square minus 4x plus 4. Right? Now if it is like this and if I have to find the zeros of this polynomial, what I will do? I will write x square minus 4x plus 4 equal to 0, isn't it? And if you notice, this is nothing but this is x minus 2 whole square, which I can write as x minus 2 equal to 0. So from here you can see your both the zeros are coinciding at one point, which is x equal to 2, isn't it? The graph will look something like this. Both the zeros are at the one point. So in such a case, you will have exactly 1 0. The x coordinate of A is the only zero of the quadratic polynomial. So in case 1, we have seen you can get two zeros. Here you have seen you can get 1 0. Now I am moving to the third case. Now the third case, here the graph is either completely above the x-axis or completely below the x-axis, and it will not cut x-axis at any point. Now I'm going to explain this by taking one example. Suppose my quadratic polynomial is x square plus 4x plus 5, and I'm going to plot the table for it for different values of x. So when x is minus 2, this polynomial value is 1. When x is minus 1, it is 2. When x is minus 4, it is 5. Okay, and when I plotted the graph for this, I have got something like this. And you can see here the parabola is not intersecting at all on the x-axis. Okay, so there will be two cases. Here it is above the x-axis. You will see a case where it will be the it can be below the x-axis also, but it will not cut the x-axis at any point. Okay, so we have done three cases in quadratic polynomial. Okay, so there can be three cases. Either the parabola will cut the x-axis at 2 points, or exactly it will cut at 1 point, and the third is it will completely above the x-axis or below the x-axis. So it will not cut the x-axis at any point. So there are three cases for it. Okay, so let me generalize this third case. So in the third case, what will happen? The graph will be either above the x-axis or it can be below the x-axis. So it is not intersecting anywhere in the x-axis, isn't it? So the quadratic polynomial will have no zero in this case. So for quadratic polynomial, you can see that it will have two distinct, it can have either two distinct zero or two equal zeros or no zero. This means the polynomial will have degree 2 has at most two zeros. Now what is the meaning of at most two zero? Many children get confused when it is at most and when it is at least. At most two zero means it can have either 0, it can have 1 0, or it can have two zeros. Okay, so in the case 1 we have seen it was having two zeros because it was intersecting the x-axis at 2 points. Then we saw the second case where it was intersecting x-axis exactly at 1 point, where both the zeros were coincide on the same point. And the third case we have seen where the graph was either completely above the x-axis or completely below the x-axis. So in such a case, you will not get any zeros. So these are the three cases, and this is the meaning of at most. At most may either equal to 2 or less than 2, isn't it? And at least 2 means it will be either 2 or more than 2. So don't get confused with the terms. At most means either 2 or less than 2. Less than 2 means 2, 1, 0. Don't go for negative number. It is just 2, 1 and 0. At least means it will be either 2 or more than 2. So like 2, 3, 4 and so on. So hope it is clear now. I have explained geometrical meaning of linear polynomial as well as quadratic polynomial. Now you can go through your textbook where they have given the graph for the cubic polynomial also. Okay. Now geometrical meaning of a zero of a cubic polynomial. So any polynomial of degree 3 can have at most 3 zeros. Like we have seen in a quadratic polynomial, it was having at most 2 zeros, right? Either 2, 1 or 0. Here it is at most 3 zeros means either it will be 3 or 2 or 1 or 0. These many possibilities are there for a cubic polynomial. So in general, now if you generalize the geometrical meaning of linear polynomial, quadratic polynomial and cubic polynomial, you will see that a polynomial px of degree n, the graph of y equal to px intersects the x-axis at most n point. Okay, now depending on your degree, this n you have to change. If it is 2, then it will have at most 2 points, which you have seen in quadratic. If it is degree is 3, it will have at most 3 points, which you have seen in cubic polynomial. Therefore, a polynomial px of degree n has at most n zeros. So that's all for today's class. I have covered all the geometrical meaning of linear, quadratic and cubic polynomial. Now in my next video, I will be covering the first exercise of this chapter along with example question. And those who did not subscribe to my channel, please subscribe to my channel for more helpful videos. That's all for today's class. Thank you.